Okay, guys, so let's start over chapter number 4. So, chapter 4 is about authentication, and I have divided this chapter into 4 parts. It's a very long chapter, so we have mainly 3 things to discuss in chapter number 4. Starting with the elements of authentication, where we will discuss the authentication factors. Then we will discuss password attacks in detail, and we will discuss defensive scheme, how we can avoid those password attacks. And the last is OAuth. It's the authentication model for internet applications. We will talk about OAuth in detail, and then we will also discuss some formal authentication models that we use in our network. So, starting with our first agenda item, and in the first part of this video, we're going to talk about elements of authentication. Specifically, we will discuss one factor, that is knowledge-based authentication, and specifically we'll discuss few probabilistic password attacks. We'll discuss the defensive schemes in the next video. So let's start with our first agenda item, elements of authentication. So authentication, if we would like to define authentication, what is basically authentication? So authentication is basically verification of credential, or you can say authentication is a process. It is a process of verifying a user or device identity. So a process of verifying a user or device identity is called authentication. Now the thing is, how typically we perform authentication. So the most common form of authentication, the most common you can say authentication scheme is, the most common authentication scheme is username and password. So we typically use username and password to perform authentication. And in username and password approach, the legitimate users are provided with unique user ID, or you can say username, and secret password. That's a typical approach. So they are provided with a unique user ID and the password. If users want to access protected resources, then they input their credentials. Like credential means username and password. They input their credentials to authentication servers, and if a match occurs, then they will be given access. They will get the access. Otherwise, not. Otherwise, the request will be turned down. So that's a typical model of authentication. So for example, if you want to access a protected resource, you have to prove your ID. You have to your username and password are basically the traits or parameters through which we can perform authentication. There are many other parameters or factors as well that we can use, and we will be talking about that. So authentication, a process of verifying user or device identity, how we can do that. So if you have a protected resource, we provide username and password to our legitimate user. If they want to access that resource, they have to present their username and password. So what are the different factors of authentication? So mainly there are 5 factors of authentication. There are 5 factors through which users can be authenticated. Number 1, the first factor is called knowledge-based authentication. Knowledge-based authentication. And what is basically knowledge-based authentication? Where users have to memorize something like username and password. Username and password. The second factor of authentication that can be used, it's called token-based authentication. Token-based authentication involve typical tokens we will see in the next video, and cards like RFID card, your the magnetic strip-based card, stuff like that. Number three is the unique attribute-based authentication, or you can say your unique features-based authentication, which are basically biometrics. The fingerprints, retina eye, speaker recognition, we will discuss all of them in detail. Number four is the location-based authentication. Location-based authentication is basically your IP address. And you might have seen most of the web servers, like the email servers, they actually use location-based authentication. They do that. Number five is the action-based authentication. It's a new kind of authentication. We will discuss that. In action-based authentication is basically authenticating anybody through their keystrokes. So it's called keystroke dynamics-based authentication. So if we use just a username and password approach to perform authentication, so we are using knowledge-based authentication. If you use two or more factors to perform authentication, it is called multi-factor authentication. So what is MFA? Multi-factor authentication. Use of two or more factors to perform authentication. It is called multi-factor authentication. For example, let me give you an example. For example, your ATM card. So ATM card mainly belongs to the token. So it basically belongs to token-based authentication. But for example, if you want to withdraw your cash from your bank account, so along with the ATM card, you also need the PIN code. You need to memorize a PIN code, and that PIN code is basically it belongs to knowledge-based authentication. So PIN code plus ATM, that is basically MFA, multi-factor authentication. Okay. So let's start with the knowledge-based authentication. The most common type of authentication, most widely used authentication model or factor is the knowledge-based authentication. Let's start our discussion for knowledge-based authentication. Let's discuss few traits and how knowledge-based authentication can be implemented. So let's start with them, and then we will discuss all of them in detail. So today we're going to talk about knowledge-based authentication. So the knowledge-based authentication, if you see here, okay, so in the knowledge-based authentication, if you see down here, it's a very simple approach. Like user, let's say this is the user. User is provided with username and password. Unique username. Username is unique, but password are not unique. Password are basically secret. So users are provided with username and password, and this is the resource which we are trying to protect, for which we need to ensure security. So we have an authentication database here, and in this database we have the list of legitimate username and the passwords. So if you see, if user want to access this particular resource, user will enter username and password. Whatever user will enter, it will directly go to the authentication database. Authentication database will find a match in the database. If a match occurs, then user can access the resource, otherwise not. So let's say if the username is Alice, the password is, for example, 1234. If it goes to the database, authentication database will check the database, Alice, and the password. If the match occur, user can access resource, otherwise not. So this knowledge-based authentication, they mainly provide two levels of security. So mainly if you see, there are two levels of security. Number one, user identification. They provide user identification. Number two, they also provide user authentication. For user identification, user has to remember user ID. So users have to remember or memorize user ID. And for user authentication, they have to memorize the password. Okay, that's basically kind of two level of security. Very simple process that we discussed. Username and password. If it goes to the this combination goes to authentication database. If a match occur, user can access. Otherwise, not. That's knowledge-based authentication. So user has to memorize something to perform to prove his authentication. Now, what are the weaknesses of password approach? Now, there are plenty of weaknesses. Number one, the first weakness is, like, as you know, in today's era, we have, I mean, where everything is going over internet. So we have, many online accounts. We have many online accounts nowadays, and it is impossible to memorize different password for all the accounts. The difficult password, like, since we have many online account, like, let me just give you my example. Like, I have 30 to 40 different accounts. Okay, so it is impossible for me to memorize 30 to 40 different passwords. And on the top of it, if I just make it more hard to crack, so difficult password, it is impossible. Look, no, it is impossible. Being a human, it is impossible. Now, what people actually do, they use many online password. So people use same password for all of their accounts. So people, they actually use usually same password for all of their account. According to Google, in 2019, Google, they did a survey, and they actually found 65% of internet users who actually use Google as well, Gmail and all their products, they use the same password. They have the same password for all Google accounts. So like 65% of the people, they have the same password. That's a problem. Like, if you use the same password for all the account, if that password gets compromised, you are done. Second weakness of the password is the people, what they do, they actually use short or simple passwords. So they can easily memorize, which can be easily memorized, because this is something that you have to memorize. So people, they use short or simple password so they can easily memorize. And again, that's a risky kind of short, in fact. Like, if you use short password or simple, it can be easily guessed. People can easily crack your password. In 2019, the same year, British agency, which is National Cyber Security Center, it's a British agency, they actually did a project, and they found 23 million online accounts having 1 2 3 4 5 6 as a password. So, I mean, this is just one example, and you will see a lot of people around you, they might have the 1 2 3 4 5 6 the password. And most of the cracking software, they have this particular password in their dictionary, because that's just imagine 23 million accounts having this particular password. Other than that, shoulder surfing is another problem, which is, of course, a social engineering attack. Shoulder surfing, that's another problem with the password. Like, it is the problem at your home, at your work, everywhere. Shoulder surfing, people can actually stand behind you when you're typing the password. So these are typically the weaknesses of the password. We cannot actually memorize different and difficult password, having enormous amount of accounts. So people, they use same password. People, they use short or simple password so they can easily memorize. And shoulder surfing is another problem when you are typing in the password. So we will discuss the solutions. We will discuss all the solutions, how we can get rid of it, how we can actually make our password more robust, more strong. We will talk about it in password management strategies. Number two is next is the attacks on password. Let me just tell you one thing. Even though the password, this particular approach has received many attacks, like people, they report many vulnerabilities of passwords. They come up with new software of password cracking attack, but still it is the most widely used approach. For attacks on the password, there are mainly three main approaches of the password attacks. So password attacks, there are three main approaches. One is the social engineering. Second, password attacks are basically, you can say, sniffing or capturing. The third is the offline tracking. And most of the passwords are basically password cracking software. They are basically offline tracking software. Social engineering, as we already talked about, trick the people to get their information, and there are plenty of ways to do that, like shoulder surfing, which we talked about, shoulder surfing, phishing, wishing, dumpster diving, etc., etc. Sniffing, people, they actually use keyloggers, which you guys have might seen in the lab 3. If not, then you will see in the lab 3. Keyloggers and protocol analyzers. Protocol analyzers like Wireshark, where they actually sniff the packets. Offline tracking, there are plenty of ways to perform offline tracking. One is the brute force attack model. Like try all possible combinations. Probabilistic models. Then we have the probabilistic model. Then we have the dictionary attack models. Then we have the rainbow attack model. Rainbow tables. We will see all these stuff in a while. So social engineering, as we already talked about, it's just basically just trick the people over email. It's called phishing. Just trick the people to get their classified or confidential information. Like tricking the people, like they can be tricked by using email, phishing. They can be tricking over phone, which is called phishing. Some people, they can get information through the like some people, they write down the password on their papers or somewhere, I mean on the table as well, on the sticky note sometime. So dumpster diving, like collection of information from using the unshredded pages or the trash maybe. That's basically social engineering attack. It's a simple way to guess or to actually get somebody's password. Then the capturing. In order to capture, it's the simplest way to find someone's password. It's the simplest way. Like you don't have to do any kind of you don't have to actually plan any kind of con maybe for social engineering that you don't have to even use the tools, the password tracking tools. It's the simplest way. How capturing can be performed? People, they use keyloggers, or they use protocol analyzers, packet sniffer. So in the keyloggers, they capture the keystrokes, like victim's keystroke, in fact, keystroke, and sends the keystrokes to attacker or make a log for later access. So whatever user will type, they can actually make a log. In our online class, I'll show you one of the keylogger. It's called KidLogger. I'll show you in our online class. Protocol analyzer like Wireshark, like bsniff. What they can do is these particular software could be, they are basically specialized software And there are a few hardware as well, like which can be installed on Raspberry Pi, hardware that can monitor, capture, or you can say monitor the network traffic transmitted over the network, okay. And they can easily capture whatever you have transmitted. If you remember, I've shown you guys, if anybody access HTTP website and put username and password, if anybody knows your IP address and they are spying you or they're collecting your packets, they can see whatever you have transmitted. HTTPS, it makes it slightly hard because the data goes in encrypted form, but if anybody is using DSNF, they can still crack it. Let's come to our offline tracking. So offline tracking is something like, it's basically like more kind of technical attack. In offline tracking, attackers, they actually steal the hash file. Please remember one thing here. Password, to ensure the security of password, the passwords are not stored in plain text form. So passwords are not stored in plain text form even on your own computer, even on personal computer as well. So passwords are stored in hash form. Okay, there are a few things that I will tell you about hash form, but let me just tell you one thing. For example, let's say you have created a password Alice. So if you want to set up your password on your Windows computer, your Windows machine will use NTLM or let's say MD5, this hash algorithm, and calculate a hash. Let's say hash is hashtag FAE1, something like that. So this particular hash value will be stored on your computer. So whenever you want to access your computer, whenever you type Alice, your computer will calculate a hash value and compare the hash value with the stored hash. If both values coincide, then user can access, otherwise user cannot access the system. So what are the beauty of hash function? First of all, please remember hash functions are used for integrity, not for confidentiality. Why? Because hash functions are irreversible like one-way function. One-way mean, let's say this is Alice. If you calculate the hash value of Alice, like hash value, let's say FAEO, something like that. So if anybody knows this value, they cannot actually get the Alice back. It is theoretically impossible to crack or reverse it. One way you can only get, you can only go in one direction. Second, it gives same size output regardless the length of input. So whatever your input is, whatever the size of input is, you will get the same size hash value. For example, let's say you use MD5 for hashing. Let's say this is the MD5 algorithm that you're using. So for example, if you calculate hello, so we have 1, 2, 3, 4, 5, so 5 letters. If you calculate the hash value for hello, let's say it comes FAE hashtag 1, for example. If you calculate the hash, for example, using the same algorithm, if you calculate hello 1, 2, 3, 4, 5, 6, 7, if you calculate it, you will get, let's say, ZX hashtag 1, 2, exactly of the same size as of any, so it is independent of the input. The size of the output of hash functions are independent of the input. So in most of the offline cracking, what attackers they do, they steal your hash value from the victim's computer, and then they try to guess it. And by guessing mean they use dictionary, they use rainbow tables in order to do that. So let's see what are the different offline cracking methods. The first is the brute force attack model. Brute force attack model is basically attacker tries all possible combinations. Attacker tries all possible combinations of letters, you can say numbers, characters, and combination of them, and combination of special characters as well. So attacker tries each and every possibility in order to guess the password. So success rate is 100%. Success rate is 100%, but because of its cumbersome nature, because of the cumbersome nature, it may require impractical time frame. So basically, I mean, you're trying everything and try to guess the password. So you never know how you will succeed. But again, the success rate is 100%, of course, because you are trying everything to guess the password. Next is the dictionary attack that we already discussed in our other classes as well. In the dictionary attack, what's going to happen? In dictionary attack, first of all, attacker has stolen the hash value. Let's say this hash value has been stolen. Attacker has stolen the hash value, but attacker need to guess it. So attacker will create a dictionary of the password. Like attacker will create the dictionary of all password and then calculate a hash value. So now attacker has the hashes of all the known password. Then attacker will make a comparison between the stolen hash and all of these hashes. If a match occurs, then what will happen? We guess the password because we know all the passwords or all the plain text of these hashes. Okay, this is called dictionary attack. But in dictionary attack, we mainly use biased dictionary. Biased dictionary mean password associated with the, you can say, the person who's like for example, I'm just gonna crack the password for Alice, for example. So I will create a dictionary of the password associated with Alice, for example. So password associated with the person whose password is being guessed. Okay, so rather than trying all those stupid combination, why don't we try something which that person might have? So attacker create a biased dictionary of the password associated. There's a likelihood that that particular person may have that dictionary. So you know what, if we use a general kind of dictionary, so search space will be a lot. Like search space mean the possible passwords in dictionary. So possible, like number of possibilities. So possible password in dictionary is called search space. If you have a biased dictionary, you will have small search space. If you have small search space, automatically what will happen? The speed of attack will be faster. Like if the search space is too big, automatically what will happen? You will have a lot of hashes, and then comparison with each and every will take a lot of time. But if you have a short or small dictionary, it will take less time to guess the password. And especially with the biased dictionary attack, there is a more probability that you can guess, you can actually get the password. Next is the rainbow tables. Now in rainbow table, what happens? Usually these rainbow tables are the database of pre-computed hashes. Since it's already pre-computed hashes, so it is faster than dictionary and brute force attack. Okay, it is much faster because you already have pre-computed hashes. You don't have to actually create a hash function. For example, you don't have to actually calculate hashes, just like right here, where you have to firstly create a dictionary of the password. In the bias dictionary, likelihood, or you can say something, the password associated with that person whose password is being cracked. You need to create that dictionary, and they'll calculate hashes, and then a comparison. So in the rainbow attack model, you have already hash tables, like just like this hash table. You might have plenty of hash tables there, and then you just have to make a comparison, nothing else. So it is faster than dictionary and brute force attack model. But and again, you can download the rainbow tables independently, or these rainbow tables come with John the Ripper and the OPH crack. So in OPH crack, there's an option for rainbow table. If you select rainbow table, they have already pre-computed hashes, and you can guess the password using rainbow table. In rainbow table, there are mainly two things. The first step is you need to create a table creation. But as I already mentioned here, table creation means pre-computed hash. So if you have already those table, that's perfect. If you don't have the table, then you have in rainbow table, you have to create the table. After creating the table, then password cracking. Password guessing, or you can call it password cracking. These are the two steps involved in rainbow table. As I already mentioned, rainbow tables are already, it's very common. You can find a lot of rainbow tables, so you don't have to actually worry about how I can get the rainbow table. But how to create a table? Let me tell you. For example, if you want to create your own rainbow table, how you can do that. So the first step is table creation of table. In order to create a table, we use, in rainbow table approach, we use a function which is called reduction function. Reduction function is a very important function in rainbow table. In reduction function, what it does, it can calculate, you can say convert the hash value into the plain text, into valid plain text having the same length as of the password, having same length as of the password. So that's very important function, reduction function. So let's see how we can create a table. For example, let me give you idea. So for example, we need to create a table. So we will start with a string. So let's start with a string. Let's say string is hello 123. So let's say we are going to start our string from hello 123. The first step is we will calculate the hash value of hello 123. So the first hash value is, let's say, hash value by using, let's say, MD5. The hash value, let's say it comes F30AA7. For example, that's the hash value. After you get the first hash value, now we will calculate the reduction function of that. Reduction function. How? Like F30AA7, we will apply the reduction function, and reduction function will convert it back into, let's say, Alice PTI, for example, something like that. We got this value. Again, as I mentioned, this reduction function has a capability, it converts the hash value into plain text back of the same length. You can see the length is exactly the same as that of this. Now, the next step is we will again calculate the hash value of this plain text. Alice PDI, calculate the hash value, MD5, we will get something, let's say 2B, for example, 1296, something like that. Okay, we will repeat this process. So now again we will calculate the reduction function. So we need to create a chain of that particular process. We will repeat the process over and over in order to get a complete table. So in our case, the table is going to be hello 123 F30 AA7. Then if you remember, we took the reduction function Alice PDI. Again, we calculated the hash value, let's say 2B1296. So that's hash value. Again, we will apply reduction function. So this is hash reduction, hash reduction, let's say it comes cat I990E, for example. Okay, so you will have, this is one hash table, this is one, by the way, hash table. So in the rainbow tables, in the rainbow table, we have plenty of hash tables like that. Maybe we have 50 or 100 tables like that, okay, in the in our practical rainbow table attack. So that's the first step. We need to create a table. So that's the way how we will create a table. Now, in the second step, where we will guess or crack password. So what's basically our second step? In the second step, what we're going to do is we will actually, we need to steal that hash value. So let's say, for example, we have stolen a hash value, and hash value is, for example, 2B1296. I just want to actually show you guys, so that's why I took that. So for example, this is our stolen hash. Stolen hash. So first step, what we're going to do is, the first step is we will calculate reduction function of stolen hash. So if we apply stolen hash reduction function 2B1296, we will apply reduction function, and let's say we got cat I90E, something like that, because it's the same reduction function. Now what will happen here? We will actually, we got this value. Now we will actually refer to our all hash tables, like rainbow tables, and see if this value is at the start or ending of any of the table, or starting and ending, because we know the starting and ending of the table. We will find this value. If we find this value on any of the table, then we start traversing that particular table to find the actual password. So for example, in our case, we were lucky enough, this value, the reduction value, we found this value is down here in the table number 1, for example. So we will go back to table number 1 and traverse it, like hello, and this was the hash value. Okay, so that's not the hash value that we were looking for. Then we will go to the next LSPDI, and that's the hash value of this. So for this hash value, that's the password. So this is, by the way, LSPDI. So LSPDI is the password. Again, let me just tell you one thing. It is not mandatory that that's the password, but this is the value which provides the same hash as that of the original password maybe. So what does it mean? It means if you enter this particular password, you will be given access. Why? Because it is giving you the same hash value as that of the original password. That is called the rainbow attack. Birthday attack model is very similar. In birthday attack model, we use the word and find the hash value for the stolen one. For example, let's say you stole the hash value like XYZ123, we will actually find the word having the same hash value in the birthday attack model. So if you see down here, that's the process, that's the word through which we can get the same hash value. So this is the way how rainbow table actually work. We can discuss that in detail. If anybody will have any issues, we can discuss that in detail as well. Okay, so please remember, these tables are already available. You don't have to actually worry about this table. So in the rainbow attack model, you are given with all these tables. You have maybe 100 or 200 tables, and then you are given with the reduction function. All you have to do is enter the hash value, stolen hash, and then it will tell you whether what's the password, whether the rainbow table can crack this password or not. So how to create the password? We use reduction function. We create this string. And then in the second part, how to guess the password, you should have to steal the hash value, calculate the reduction value, find which table from which table it belongs to, and then we traverse that table to find our original password. So that's it for today, and we will discuss the probabilistic attack in our next class, and we will also discuss the defense methodologies, how we can avoid the password attacks and stuff like that. Thank you.